Good morning, everybody. Welcome to ISAP's Risk Management Conference. We'll get started here in just 1 minute. All right, so thanks for joining, everyone. Good morning and welcome to ISAP's 2024 Risk Management Conference, a 3-part webinar series to future-proof your farm. This is week 1, where we're going to be focusing on pest management and herbicide resistance. And if you haven't already registered for the entire series, please do. But we are recording the webinars for future viewing as well. So you might have gotten that notification as you came into the room this morning. So let's get started. My name is Megan Baskerville. I'm the Illinois Ag Program Director for the Nature Conservancy and currently serving as Vice President of the Illinois Sustainable Ag Partnership, or ISAP. ISAP is a coalition of 15 member organizations. You can see their individual logos here on the screen. And we're all working to improve soil health and water quality by promoting the adoption of conservation cropping systems. ISAP formed back in 2017 in response to Illinois' nutrient loss reduction strategy, and we focus on providing technical, pragmatic resources to Illinois' farmers and crop advisors on best practices to reduce nutrient losses and meet sustainability goals across Illinois' 26 million acres of ag lands. For today's webinar series, I am joined by ISAP colleagues Frank Rademacher, who will meet in a bit, Rachel Lechuga and Helen Van Beck running slides and tech troubleshooting, and Tori Colburn, who will moderate today's Q&A session. I will, of course, do a short shameless plug, though, before we get going. Besides this risk management conference, there are multiple ways that you can stay plugged in to ISAP's resources, and we wanted to share a few of them with you today. So first up, we have ISAP's newsletter, The Aggregate. It's published monthly, and that's where we include upcoming events, learning opportunities, job openings, technical resources, you have it. So you can sign up there on the ISAP website, and you'll also see some information trickle through in the chat box throughout the day. We also host ICON, the Illinois Cover Crop On-Farm Network. This is a monthly call for crop advisors to share their perspectives from the field as they work with clients to implement cover crops across the state. So related to today's series, ICON is in the midst of a summer series on weeds, diseases, and pests. So quite a cheery summer series that you could join in on. You can sign up to be a part of that community of practice also through our various web links here, and you'll get notifications on that as well. I think it's the first Wednesday of the month. So thank you for going through those ISAP resources. I will now kick it over to my colleague, Frank Rademacher, to get us started on today's conference.
Awesome. Thanks, Megan. Good morning, everybody. And again, welcome to the to ISAP's 2024 Risk Management Conference. We do hold this webinar series every other year and really try to highlight how conservation practices can serve you and help mitigate production risk on your farms. So we're happy to have in attendance today a great mix of farmers, advisors, landowners, educators, researchers, and more. And like Megan said, today I'm joined by Tori Colburn of AFT, and who will be helping moderate the Q&A session, and also Helen Van Beck and Rachel Lechuga, who will be running things behind the scenes. So again, huge thanks to the team for helping put this together. If you can go to perfect next slide. So yeah, this year, the theme of the conference is future-proof your farm. It seems like a lot of farming really lends itself to like a seasonal planning cycle year by year. And because of this, a lot of times production risks that really take years and almost sometimes decades to develop seem to happen overnight. Sometimes, 1 year it seems like your herbicide doesn't work, or weather events that used to be extreme are now kind of the norm. So really our goal in this conference is to highlight how conservation practices can be concrete steps that farmers and advisors can take right now to prepare for those ongoing current and future threats to farming. Perfect. So Today, we decided to focus on pest management as a big one, always top of mind for everyone. And so we'll be hearing from Dr. Bryan Young, Dr. Jonathon Lundgren, and then due to a last minute scheduling conflict, me. We were really happy to have both of our experts here, and bear with me for my session at least. So after those sessions, we'll have a roundtable Q&A session. And so when you do have questions during the course of the event, please do message our hosts directly or the group chat to everybody, and we'll get to those at the end of the conference. So now I think we'll go ahead and hand it over to Dr. Young, our first speaker. Bryan is a professor of weed science in the Department of Botany and Plant Pathology at Purdue University. Bryan earned his bachelor's degree in crop and soil science at Michigan State University and doctorate in crop science with a specialization in weed science from the University of Illinois. Bryan has held an academic appointment with teaching, research, and outreach activities for over 26 years. Bryan's research and education at Purdue focuses on weed biology and ecology, herbicide application technology, and characterizing herbicide resistance in weeds. So whenever you're ready, Bryan, go for it. I think we'll let you share your screen now.
Okay. All right, so I hope everybody can see my screen now. Good morning, everyone. Thank you for the invitation to join today. It's a pleasure. I always love talking about weed management, even though sometimes I don't paint a rosy picture. I always enjoy talking about some of the challenges and how we can overcome some of these challenges. And that's the goal for today, is that we talk about what do we have to do in the future to become more effective at managing weeds. It's going to be a short presentation, but I hope to get a lot of questions at the end during the panel discussion. So let's go through this. And the first thing I need to do, though, is establish where we are today with weeds. They're not becoming any more easy to manage, for sure. We have weeds with multiple resistance to different herbicide groups or modes of action. We have weeds that have outlasted our herbicide discovery efforts. In other words, we haven't had a lot of herbicide discovery to bring new novel herbicides to market because glyphosate was so effective for the last 20 some years, or at least a good 10 to 15 of that, that discovering new herbicides just wasn't a priority. And it's hard to kickstart that system again, especially with some of the regulatory hurdles that we have to make sure that it's safe for the environment and for people to use. And then we selected for weeds that, if you think about some of the biggest problems, the amaranthus, like palmer amaranth, water hemp, mare's tail, or horseweed. These are very small seeds that are produced on these plants, and these plants can produce thousands of these seeds. So state of Indiana, we had a giant ragweed issue. It used to be the state tree, but those seeds don't disperse quite as easily as these small seeds. They can float, they can blow in the wind, they can get hung up on equipment, they can move in our grain, they can move in our feed. So these weeds that we have today that are herbicide resistant and providing a challenge, they've been able to adapt to our system of crop production. So unfortunately, I have to give you an update on where we are at with some herbicide resistance. That might be new information, or you might have experienced it so far this year. But through United Soybean Board, I have managed a group of weed scientists throughout the Midwest and some in the Mid-South for screening herbicide resistance in water hemp and palmer amaranth. I'm just going to focus on water hemp today, to important herbicides, 2,4-D, dicamba, and Liberty or glufosinate, because those are the herbicides that we use in soybean today for management, and to some extent in corn. So I'm just showing on this photo here where in a greenhouse situation where we applied a field use rate of glufosinate or Liberty, we have some plants of water hemp that died and some that certainly lived, different populations. And you can see that for some of the plants, we just kind of burnt the leaf tip, and that's all the activity that we observed. Here's looking at a field use rate of 2,4-D, definitely surviving the 1X rate in the greenhouse. And you can see, yes, the test is good. We are killing some, but some after that initial hit with the herbicide, they're able to regrow and produce seed. So let's look at maps. Who's impacted? What county are you in? This is color-coded to show that in our greenhouse research, where we applied a 1X rate of these herbicides, what percent mortality did we get? If we had 100 plants, did 75 plants die, or did less than 75 plants die? And so in this color coding, the orange would be where we had less than 75% of the plants from a specific field population that died. So those would be the greatest concern. It'd be great if your county is maybe in that light blue, because that means they're all dying from the herbicide. But if we look at water hemp and glufosinate or Liberty, well, Southern Illinois, Missouri, maybe East Central Illinois, West Central Indiana, that's where we've had water hemp problems for a significant period of time. And we have used glufosinate probably more than other geographies. And so that's where we're having some challenges where some of the populations, we're not killing all the plants like we would normally. And I want to make sure it's understood. We're not calling these plants resistant. We're doing further research. These are counties of concern. Moving to dicamba, well, a lot of counties of concern in terms of applying a 1X rate in the greenhouse and not having at least 75% of those plants dying. And then 2,4-D, similar story, not as extensive as dicamba because we started using dicamba in soybean a little bit earlier than what we have 2,4-D, and we use probably dicamba more so in corn than what we do with 2,4-D. But certainly we have some counties, and you can see that some of these counties have been highlighted in orange for both, or not both, but for 2,4-D, for dicamba, and for glufosinate. So that is not good news if you're looking for herbicide options moving forward in a post-emergence application. The other thing we hear about is metabolic resistance as a mechanism for weeds being resistant to herbicides. Now, this isn't anything new. Our atrazine resistance, Pat Tran at the University of Illinois would suggest that most of the resistance we have in water hemp to atrazine is metabolic in nature. They've also documented at University of Illinois that there's metabolism-based resistance at the group 15 herbicides like a Dual or a Warrant or a Zidua. And then for the group 27 herbicides like a Callisto or a Armazon, those are all primarily metabolism-based resistance mechanisms. Now, the downside with metabolic resistance is that single mechanism may allow resistance not to just one herbicide mode of action group, but multiple modes of action groups. So that's where the challenge comes in, that you might have group 27 resistance, but it also allows for maybe some resistance to possibly a group 4 herbicide, an auxin herbicide, or maybe a group 27, a bleaching herbicide. And so that's the challenge moving forward, this metabolic resistance, which we typically think of low-level resistance, but still significant in the field. Other forms of resistance that have some association with metabolism be resistance to ALS inhibiting herbicides in water hemp, and then the group 14 herbicides. That's been confirmed in an amaranthus population down in Arkansas, not to any extent yet in the Midwest, but I think it's probably there. We just haven't confirmed it. So we have a weedy mess with multiple resistance. If we had easy solutions for it, we wouldn't be talking about this problem. But instead, we're talking about new crop traits, but they happen to be for older herbicide chemistry. That's where we've been. We have new regulatory constraints. I hear from those in herbicide discovery that anything over 100 grams per hectare, and so that'd be about 0.1 pounds of active ingredient per acre. Anything that requires a rate above that, they might not bother bringing to market because it might be frowned on, loading the environment with too much active ingredient, or maybe just production costs are too high. But if we were to eliminate all the herbicides that are applied at greater than 0.1 pounds per acre, glyphosate, 2,4-D, dicamba, glufosinate, paraquat, atrazine, metribuzin, the list goes on and on. So the challenge to find new chemistry is really significant today, more so than it was 30 years ago. So what are we going to continue to see in terms of bringing new technologies to market and improving weed management? Well, we're going to see that herbicide-resistant crops. I'll talk about that in a little bit. Herbicide safeners, so such as Corvus formulation of balanced herbicide or isoxaflutol. Those work in corn. We don't have any safeners in soybean that have been proven effective over the last 50, 60 years. So the outlook for safeners to improve weed to be applied with a herbicide in soybean, probably not very likely. But certainly in corn, we continue to use that to bring new herbicide molecules and apply them safely in corn. Herbicide encapsulations, such as the acetochlor encapsulation to make the warrant formulation that can be safely applied in soybean. That's through encapsulation. And I see this with other herbicides. A new one from BSF just this past year was Certain for applications in corn of sharpen or saflufenicil that's encapsulated, so it can be applied post-emergence on corn and not burn your leaves extensively. Something that kind of went back on the shelf, but Monsanto was working on something called BioDirect, and that essentially RNAi technology. So you silence genes. They're using for insect management, but for weed management, they kind of shelved the idea because they were busy with some extend systems, let's just say, in soybean that they are trying to, support the market for. But there are multiple companies now working on RNAi. So can we silence genes? So not just silence a resistance gene in a weed, but we'll be able to maybe just silence the gene that encodes the enzyme that we used to use herbicides to inhibit that enzyme. Now we just eliminate the enzyme. That is a possibility moving forward. Has it been demonstrated in the field? Yes. Is it consistent? Well, not quite yet. That's where the problem is. And then last, automation, precision ag, targeted spray, see and spray. I think these things are going to continue to evolve to improve possibly the simplicity of how we manage weeds, because again, a lot of our solutions have made life more complex. Hopefully these might make things a little bit easier. So let's look at the traits real quick. Here's just one pipeline from Bayer in terms of their genetics. Pioneer and other seed companies are going to have their pipelines as well. But in blue, we have the herbicide resistance traits. So you hear about HT4 technology in corn and soybean, and that's really taking the resistance traits that we have in currently commercial hybrids and varieties and putting them into a single bag, if you will. So a single hybrid or variety. So it doesn't encompass any new traits there, just stacking them together. But then we have the HT5 over here for corn and soybean. That's where we do get a new trait involved. So let's look at that a little bit more in detail. So HT4, you have glyphosate and glufosinate. So Roundup and Liberty, dicamba, 2,4-D, and the HPPD resistance that we have in LLGT27 soybeans. But it's all going to be in one variety or one hybrid. So that's where you have flexibility for managing weeds, and you don't paint yourself into a corner because you really wanted that other herbicide, but it didn't come as a stack with your 2,4-D resistance, or it didn't come with HPPD resistance. So that's going to give us more flexibility. Commercially, these are approved for sale this year by the APHIS USDA. However, because of export regulations and acceptance, commercial launch isn't anticipated until maybe 2027. That's depending on approval overseas where we export our grain. HT5 has the same traits as HT4, except we include this PPO tolerance trait, which is new. Several companies are working with it, but it allows us to use higher rates of older herbicides. So envision Valor, which is PPO inhibiting herbicide, but applied maybe at 2 to 3, maybe even 4 times the use rate that you use today and have good crop safety. And that can overcome a lot of the PPO herbicide resistance we have today in water hemp, at least initially. Weeds will always adapt. But that also allows us to look at some PPO herbicide chemistry that's been put on the shelves in the discovery process because they weren't selective. They would kill your corn or soybeans. They would kill some weeds, but they didn't have any safety. So now it allows us to look at that chemistry over again and maybe have some more robust chemistry for weed control with good crop safety. So if we look at all the technologies, mechanical, we have some automation going on here, some robots. There's the BioDirect. Weed zapper, cover crops, flame weed control, harvest weed seed control techniques. There's a lot of different things that we can do. we typically end up with genetics and herbicides because that is the path of least resistance. Some of these other technologies have been tried. Now, I think it's unfortunate that when we try to incorporate a non-herbicide method for weed control, ultimately you see the equipment for sale on Facebook. And so that's what I just pulled off just this week. I saw a between row mower to mow down some weeds, and then a weed zapper up top here. A lot of these are being used in organic production systems, but could be used in conventional systems where we just run out of other tools because of herbicide resistance. One thing I'll focus on at the last portion of the presentation today is two different technologies, or one's a practice, I guess, cover crops. Another one would be a technology, targeted sprays like See and Spray. Again, it's not just John Deere and See and Spray. Other companies have it, but in our research, I actually did use the See and Spray boom system. So we have a site in Indiana, just like you would in Illinois, as well as other states, where the water hemp is resistant to 6 different herbicide mode of action groups listed here. This is a drone image of the site, and you can see the different blocks. We have a cover crop here, no cover crop over here, cover crop, no cover crop. This happens to be cereal rye. So you can see the blocks. You can also see some disturbing patterns in terms of the soybean rows too, which I'll explain in a little bit. What we did in this trial is we had the cover crops with and without, then we had a pre-herbicide. And we are aggressive with the pre-herbicide because we have 3 modes of action here for water hemp control, because this is a very problematic field with all the resistance that it has. But looking at the weed density at the post-application, which is important because this post-application is when if you use a targeted spray, you don't want a lot of weeds out there. The whole goal is to help reduce the pesticide that you're spraying. Just apply it where you have weeds. If you have a lot of weeds, you're not saving anything. So our goal is to reduce that population at the post timing. You can see that, well, just using the cover crop, cereal rye, we reduced the weed population by about 40–50%. Use the residual herbicide in combination with the cereal rye, and we had over 95% weed control at that post timing. And that's really what we need to strive for if we're using targeted sprays. Your residual control, or the control by the time you spray post, needs to be above 95%. So to look at that, this is no cover crop, no pre-emergence herbicide on the left, and on the right is the cereal rye with Fierce MTZ. So major improvement in the level of water hemp control. And so in terms of the spray volume, when we took the See and Spray unit across the field, no cover crop versus with cereal rye, we had up to really average 90% reduction in the foliar spray where we had cereal rye, as a component compared to no cover crop. So pretty significant. Now, the other aspect that I was interested in is we're using some herbicides that people are concerned about maybe injuring their beans too much. It could be any crop, but in this case, it's soybeans. So here we have a broadcast application of Cobra, and it caused 40 to 45% injury, no matter if we had cereal rye or not. Doesn't matter. But where we use Cobra with a selective spray, so See and Spray, that's what the SS stands for, we only applied it to about 10% of the area. So we would take that injury index from 40–45% and bring that down to just 4%. So we reduced the amount of crop injury by a factor of 10x by using a selective spray. Now we thought we'd get a little bit cute and use some herbicides that are labeled for soybean, Tough, which is Pyridate, and we reduced that injury by using a selective spray with cereal rye as well. And then we use Liberty. These are not Liberty Link beans. These are Plenish soybeans that just have a Roundup Ready trait for the identity preserved market. We did not use Roundup in the trial, but here we did, use Liberty for effective weed control. But, soybeans pretty sensitive to Liberty is what we found out. I had more hope. Here's Cobra as a broadcast treatment. And here's Cobra as a selective spray in cereal rye, where we didn't have but maybe 5 to 10% of the area being treated because we had reduced our water hemp pressure. So hopefully you can see that there's a lot less soybean injury on the right versus the left. So we take this out to 28 days after treatment. Well, Liberty continued to cause a little bit of havoc, so that's not a good choice for the spray system that we were using. See and Spray Ultimate is not intended to avoid spraying the crop. There might be some sprayers in the future that are intended to avoid the crop, but not this ultimate version that we had. And I'll just show you this. So this is soybean, and the green is soybeans that lived. And then with no cover crop, every place you see the soybeans died, that's because we had water hemp there. So it got application with the See and Spray. Right next to it, we had cereal rye. You see very few areas where we actually killed off the beans with Liberty because we had less water hemp. So I think that's technology, if we use a multifaceted approach, not just herbicide only, but cover crops and maybe selective sprays, we can see a dramatic reduction in the amount of area that needs to be sprayed. And in terms of overall control, this is a population that the grower has failed at controlling, 6-way herbicide resistance, and we're achieving with the cover crop over 97% weed control. So I think we had some success there. So in terms of best management practices moving forward, we have cultural, mechanical, and chemical means of weed control. But what I've learned after preaching about these best management practices for the last, 20 years, is it simple? Is it effective? Is it consistent? Is it cost appropriate? And the challenge is sometimes, in many cases, the answer is no compared to a herbicide. So these alternative practices don't get adopted because they're too complex for today's farm operations. So where do I see this going in the future? I continue to see cover crops as a component and, developing more creative, more effective herbicide systems rather than just 2,4-D works today. I'm going to use 2,4-D on all my acres, or I'm going to use 2,4-D plus Liberty on all my acres this year. We need to be more creative than that. So moving forward, I already mentioned some of the challenges. One of them is we still have very poor herbicide application practices. I'm standing in a commercial field here, and that water hemp that was just sprayed was almost up to my knee. That's not very timely application. We're asking too much of herbicides today. We need to integrate better application practices. And also, we need to be thinking more than just what herbicide can solve my problem this year and adopt more robust systems that can, help delay the onset of herbicide resistance. So needs for the future, small weeds, various things, but it requires integrated approach. And if I've learned anything in weed science since I started in weed science over 30 years ago, herbicides by themselves is not good enough anymore. We need some non-chemical forms of weed control. Otherwise, we're just on the treadmill of fighting weed resistance. Even when new herbicides come out, it's kind of a temporary effect or relief. So with that, I know we're going to have time for questions during the panel discussion. I appreciate your time. And if anybody wants to contact me later on, feel free to do so.
Awesome. Thanks, Brian. Appreciate it. And yeah, we do have a couple questions that we will get to at the end of the meeting. So I think for right now, I think we're going to go ahead and just hand it directly over to Dr. Lundgren. So I don't remember if you said you had slides, John, but you can go ahead and share your screen if you're going to do slides. Just a little background on Dr. Lundgren. So he received his PhD in entomology from the University of Illinois in 2004. He was a top scientist with USDA ARS for 11 years. He received the Presidential Early Career Award for Science and Engineering by the White House. And he's also served as an advisor for national grant panels and regulatory agencies on pesticide and GM crop risk. One of his priorities is to make science applicable to end users, and he regularly interacts with the public and farmers regarding pest and farm management and insect biology. He's an agroecologist, the director of the Ecdysis Foundation, which is more of the research arm of his work, and CEO of Blue Dasher Farm, an operating organic regenerative farm, or the practical demo side of his work. So I think that's all we've got. But yeah, go ahead, Dr. Lundgren, whenever you're ready.
Okay, can you guys hear and see the slideshow? Is it all going through okay?
Looks good.
All right. Yep. My name is John Lundgren. I run Ecdysis Foundation and the Thousand Farms Initiative, but I'm also a farmer. I'm about to say some pretty controversial things, not things that you're going to want to hear, but I think you need to hear them. The first, pests are never the problem. Okay? They are always a symptom. And unless you solve the problem, you are going to continue to have pest problems. You're going to continue to spend money on these pest problems. Okay? If herbicides, insecticides, fungicides were the answer to pest problems, we'd have kicked their asses 80 years ago. All right? It's time for a different way. It's time for us to start putting on our thinking caps again and start farming instead of just buying the next jug to get it done. If you need more than the bottom line to tell you why it is that this is not the answer, then here we go. One of our friends out in Montana was having problems. The early part of my career was based on assessing the risks of RNAi-based technologies, insecticides, and other pesticides on the environment, as well as ecosystem function. One of our friends out in Montana said she was having trouble with the deer in her area. 70% of these deer had genital deformities in the males. 70% of them had jaw deformities like the ones you're seeing here. These are hunter-killed animals. She asked us whether or not neonicotinoids, that insecticidal seed treatment that are totally benign, right? It just kills insects, right? It's on most of the crop seeds that you're planting right now. She wanted to know whether those neonicotinoid seed treatments that are pretty pervasive in the environment right now, whether those might be affecting these deer in her community. So me and a professor out in at South Dakota State, my co-author, hosted a graduate student, Elise Hughes-Burheim, to run a study, a toxicology study on neonicotinoids and white-tailed deer. This was a 2-year captive deer study. We administered neonicotinoids to these animals weekly at different doses. This study will never be repeated again. It was terribly difficult to run, and the resources simply aren't there in order to do this kind of work. The results were, we looked at the quantity of neonicotinoid in various body tissues around on these deer post-mortem. Spleens seem to be the magic organ in this case. So the level of imidacloprid that we were able to measure in spleens tended to scale very well with certain fitness parameters. In this case, you see fawn mortality. The more imidacloprid that you had in those animals, dead fawns had significantly higher levels of imidacloprid in their spleens than living ones did. The more imidacloprid in the spleens of these animals was associated with reduced fawn body weight, fawn organ weights. That makes sense, right? Smaller fawns, smaller organs. Thyroid hormone levels were disrupted. That's important. Fawn jawbone lengths were disrupted. Sounds familiar. In the adults, the activity levels, the more imidacloprid we found in these animals, the slower they were. It's a neurotoxin. Sounds familiar, doesn't it? Know anybody in your life with thyroid hormone levels being disrupted right now? I do. I was asked or criticized, right? That's what you were able to generate that's what you guys were able to generate in captivity. Come on, we live in the real world. What are we actually seeing out in the environment, right? So North Dakota sent us a few hundred spleens of their deer that were hunter killed, and we measured. So this is This is the amount of imidacloprid that we found in the spleen. This is what we were able to generate under controlled conditions. North Dakota deer populations had 3 times the quantity. Okay, you can replace the word imidacloprid with glyphosate, with paraquat, with 2,4-D. All right. These chemicals are getting into the environment. They are interacting with us and with animal life in ways that we cannot predict. The 1,000 Farms Initiative. We are working with thousands of farms across North America that are farming 26 different food systems across, I think, 30 states and 2 Canadian provinces that we've been visiting. This was one of our grower surveys at the end, asks the farmers, and this is preliminary data at this point, okay? We haven't gone through it with a fine-tooth comb to understand the full implications of it, but I think it's really telling. We asked them whether or not these farmers, croppers in this case, had been experiencing any of the following mental and physical health problems. Allergies, 41% of the farmers, the croppers, had allergies in them or their families. Asthma, 16%. Anxiety, 32%. Depression, and that's self-reported depression. 1/4 of all croppers are depressed. These are the national averages, not for farmers, but for society, right? 58% higher allergy levels in croppers, 100% more asthma, 200% greater depression rates. Parkinson's disease, cancer, that starts to get serious, right? In our farmers, 2,400 times greater Parkinson's rate than in normal society. 200 times the cancer rate. The pesticides that you're using on your crops right now are direct correlates with these diseases. The science is clear on this. I'm not saying this because I hate farmers, okay? I'm saying this because I care about you. It's time for a different way. It's time to wake up. If you are seeing this in your families, this is important right now. This is a turning point. All right? We need science. We need science behind regenerative food systems. We need science behind agriculture to be done right now. But it has to be done differently, and it has to be done right. It can't be done on small experiment farms that do not measure the real world, that do not respect the best management practices that farmers are developing under their farming systems. That's why we decided to start going with this 1,000 Farms Initiative. Essentially, this is a very different style of science. Have you guys heard of regenerative agriculture before? It used to be kind of a wacko term. At this point, you know, I don't think it is anymore. I think there's enough momentum behind this that we're starting to understand that, hey, you know what? Soil health and conserving life and biodiversity, promoting that on your farm leads to more nutritious food and greater economic resilience of your operation. Those are the success stories that are telling us that, right? Those success stories are very promising, right? They provide all of these promises of regenerative agriculture, that we can use this to mitigate greenhouse gas emissions using our food system. Greater soil health is one outcome, right? We can actually use this to reverse the desertification that we're observing in other places around the country right now. More profit for farmers, supporting life on these farms, reducing pollution and environmental contaminants, and then putting rural communities back on the landscape. Those are very great, you know, this could be a really wonderful thing, right? But those success stories that suggest that these may be outcomes are easily dismissed, Okay, that may work on your farm. It'll never work on mine. I can't make that work on my farm. So we decided to start running, putting some science, some data behind this, replicated science, to look at regenerative food systems across North America in contrast with other production systems. Does regenerative agriculture actually work in these key food crops? And for those farmers that are getting there, how are they doing it? Can we empirically tease out certain practices that seem to be particularly helpful in fostering and increasing the likelihood that you are going to be able to successfully transition your operation? This is where we were in 23 and 24. We crested over 1,000 farms this year. We're up to, we'll finish, we're actually measuring full scientific a battery of systems measurement on 500 more farms this year. So we'll be hitting up to 1,300 this year is our thoughts. But you see the geographic distribution. Our team from Indiana just got home yesterday, actually. They were working up along the northern tier of the state. What are we measuring on each of these farms? Number one, we're looking at the nutrition and working with the American Heart Association as well as Grantham Foundation in order to quantify the nutrient and plant biochemicals of, I think we've got like 16,000 different phytochemicals from different yield samples across these different food systems. So really important outcome or promise of regenerative ag is that food gets healthier when you raise it differently. We're looking at soil carbon down to 60 centimeters, chemistry, chemical, physical properties of the soil at different strata throughout the soil profile. Water, how fast does it go in? How well does the soil hold on to it? Those are pretty important things, whether you're getting too much rain or not enough. How your soils behave with that water, not a drainage tile, but your soils. Those are important things to know how these systems correct that. But one of the things that's really important and really unique about this study is that we are measuring biodiversity at a scale that's never been done before. We're looking at full microbial profiles and identifying, I think we're up to 10,000 plus species of bacteria and fungi within soils. Looking at entire plant communities, identifying the bugs that you're finding out there. Birds and ecoacoustic signatures from these different systems. And then finally, we're looking at the economics and management of these systems to see whether or not profit and behavior affects these sorts of outcomes, and how all of these different elements of the system are simultaneously functioning together, not just for a particular pest problem, but because our reactions to that pest problem have system-wide implications, okay? So we've got to be thinking about this as farm systems. We studied, working with General Mills, actually, we studied how to transition these farms. So we've been working in Kansas on wheat production systems, and up in Manitoba, Saskatchewan, on oat production systems, as well as Michigan on dairy systems. So these are new to regenerative food systems. And there's a question, do I just adopt a single practice in order to get there? Or do I adopt a full system? And so we decided to try to test this. We measured annually 60 farms up in those Canadian provinces, and the data is now in. We're year 6 of this transition study at this point. So it started as the oat pilot with General Mills. Now it's called 1,000 Farms because we subsumed it within our greater initiative. Yes, about 60 farms in Manitoba, Saskatchewan, and North Dakota that we're all transitioning. This is really challenging. We didn't tell them what they have to do, right? These are farmers that wanted to go regen And they adopted different strategies in order to do that were well adapted to their own operations. Okay, so these were farmer developed best management practice, not me as a scientist coming out there and telling you how you should be doing things. What was interesting is that the practices that they chose to adopt were really unexpected to me, I guess. So yes, the number of regenerative practices increased significantly as the study went on. So that's good. They're adopting regenerative practices, okay? The two practices that were most frequently adopted by these Canadian farmers were no-till adoption, increased by 29%, and livestock integration into croplands. So they were actually grazing their croplands. Maybe it was cover crops that they had included in their rotation. Maybe it was just winter grazing, but they were incorporating those animals in. That animal incorporation is super duper important. What was so interesting is that by year 3 of this study, 90% of these farmers had eliminated all fungicides and insecticides from their fields. If they went down to the coop and asked them what they should be worried about right now, what kind of laundry list of chemistries do you think they would be handed from that place that was selling them those things? Pretty extensive. But these farmers showed that when they adopted soil management practices, soil health practices, and conserving life on their farm, that they did not need those chemistries anymore. That the insect and disease pressure that they were experiencing on their farms was an artifact of how they were managing their farms. It wasn't something that they simply had to experience, okay? What we found is that, you know, everybody wants a dipstick. They want to stick it in the ground, they want to pull it out, and they want to say, okay, soil health, she's full, right? What we found is that by focusing on carbon, nutrient status of the soil, that wasn't the first thing that changed on these farms. What changed on these farms first was life. Life returned to their farms, biodiversity, bee abundance, grassland birds. I mean, we could name a whole bunch of these different groups of organisms that came back to the farm. And that's great, right? We love species. Oh, biodiversity, right? Life on farms, that's great, right? Why do we love that? Because life does things, all right? This life performs services. So one of the tests that we did was on pest management on these fields over time. So in this case, what we did is we used sentinels. So in the case of predation on insect pests, we used little caterpillars that we pinned out into the field. And then we watched how many of the caterpillars were eaten over a 1-hour period by insects. In year 0 of the study, only about 25% of those caterpillars were eaten. By year 3 of the transition, though, or year 2 in this case, depending on what you call it, year 0, it was up to 75%. It had tripled. At that point, these farmers don't need insecticides anymore. Seed predation, we put weed seeds on a dish, right? And then we counted how many of them were eaten. Wild oat is one of their biggest pest problems in these Canadian systems. We saw the same pattern happen for this key weed species. Here you see on the wild oat, those beetles just go into town. Crickets, super important in reducing seed banks. Things like this. That is biotic resistance to your pest proliferation, all right? You have to have this. And if you don't have life, then go to the bank and borrow more money because you're going to need to buy another jug. What we found that was really interesting is that the soils, those were not the first things to change. Those were artifacts of life on their farms. Without that life, farmers would have to replace what that life did in terms of generating things like fertility and carbon in their soils. They would have to replace that with other inputs, right? That function is gone at that point. What we found is that the more practices that they adopted early on, the greater their soil status was in terms of soil productivity. What that suggests to me is that these farmers, rather than simply going no-till, right, or simply putting rye out there this year, these farmers were adopting an entire system. Maybe it was intercropping, a diverse rotation, incorporating livestock to help graze full season covers that were multi-species mixes into their system on a smaller scale and then scaling it up. That was far more effective in getting them to the end goal of a successful system than just trying one practice, watching it fail and giving up. So transition is very possible, okay? We're seeing this across North America at this point, and we're meeting the farmers that are doing it. The thing about it is that you guys are, status quo isn't getting us where we have to be. Change is imminent right now. You can choose to change, or you can, I don't know. Farmers ask me what the cost of change is going to be. Wrong question. What's the cost of not changing? It'll cost you your farm. It'll cost you your grandkids. Is that worth it? There's a lot of hope right now. The farmers are showing us this hope across North America. We are meeting farmers that are successfully doing that. And there's a lot of, all it takes is one seed, right? One pebble starts an avalanche. And you guys are a part of that. So yes, that's, I think, enough. That is enough. We are crowdfunded. If you would like to register your farm to be a part of this study, scan the QR code. We'll get you involved. We give you $7,000 worth of free information about your farm, a 35-page book, all for free. So think about it, especially if you're interested in trying some new practices and need some support on that. Thank you.
Awesome. Thank you, Jonathan. Okay, so then next is me. I've tried to shorten up my presentation a little bit just in the interest of time, but after I finish up just with our on-farm experiences, we'll jump right into questions. So please do keep putting those in chat. Okay. How does that look? Can you see?
Yeah, looks good, Frank.
Okay, perfect. Okay, yeah, like I said, gonna cover just real quick what we're doing on our farm to hopefully bring those two talks together, and what this looks like at the field level for us in East Central Illinois. So my background really quick, I graduated from the U of I in 2018. I got a bachelor's in crop science with a focus on integrated pest management. So exactly what we're really talking about here today. So after graduation, started farming with my father, and still do that to this day. So we farm at the time about 600 acres, now probably closer to about 1,100. So then I also serve as the Illinois Conservation Agronomist for the Nature Conservancy. So just real quick on our farm background, after I joined, just looking at our profit picture and with another person in the operation, really tried to understand how we could change the operation to increase our profit a little bit. So we really started that transition to more regenerative ag in 2018, and eventually got to the point where we were all no-till, cover crops before both crops, all non-GMO for several years, and then insecticide-free for the last 4 or 5 years. So last couple of years, we've started to move just slightly towards a less intense direction. Like I said, we have grown the operation quite a bit in that time, and we're really trying to have an internal discussion on, our impact, our environmental impact versus the scalability of our system. So, farms are always growing and changing, and sometimes regenerative farms, it can be a little higher labor, especially as we do everything ourselves. So we're trying to build a system that would allow us to grow as well. So just real quick, so you understand when I do cover what we do for weeds, diseases, and insects, what our current suite of practices is. So we are all no-till ahead of corn. We are batting around how to maybe make that strip till. I think strip tills are really good middle point. So we plant around 38,000 plants per acre, again, being no-till into pretty decent residue sometimes. Bumping that up works a little better for us. We have 20-inch spacing for both corn and beans is a decision we made a couple of years ago. And then for seed treatment for corn, we are fungicide only. Like I said, we are non-GMO for the corn still. So we order that untreated and then have a third party put on a fungicide seed treatment. Cover crops, we've really backed this off in previous years. There were a lot of years that we were pretty aggressive and we were planting green into big cover crops. Now we've kind of moved to the point where we feel that it probably works better for us in our system to terminate those cover crops early. So we've kind of moved to a different mix that isn't quite so expensive and allows us to still reap some of those benefits, but be managed pretty flexibly over the years. So we've got 20 pounds of wheat, 20 pounds of barley, 3 pounds of winter camelina to get a brassica in there. And I drill that right after harvest. So our nitrogen program has changed a little bit over the last several years. We are back to fall anhydrous at this point. So we will put on 120 pounds of fall anhydrous with a stabilizer into those green cover crops. We feel there's pretty good research on that our losses are little to nothing under that system. And then we also surface band 60 pounds of nitrogen with the planter. And then as far as any in-season fungicide or insecticides, really, that's just a decision that we make. If a pest met a threshold, I'm out there in the field a lot. And I will say, since I've joined the operation scouting fields, we have not needed to apply a fungicide or insecticide, or really even, I don't think, come close in any years. That doesn't mean fields are perfect. There's always diseases out there. There's always insects. But again, we're trying to manage based on thresholds and our long-term goals. Soybeans. And actually, let me hop back real quick. So there's our corn planter at the side and our bean planter, obviously. So you can see there's 2 saddle tanks on the wings that we're using in-furrow products with, and then a tractor tank you can't see, and a mainframe tank that we use for nitrogen. But it is a no-till planter. It is hydraulic downforce, which has been really nice the last couple of years. And we obviously, do a lot of work to make sure that the opening discs are sharp and ready for a no-till system. Narrow gauge wheels, seed firmers, and closing wheels, spike closing wheels. For soy, we've really tried to stay flexible over the last couple of years. So we were non-GMO for since about 2018, but have made a switch. Actually, got some seed contracts, so we're doing some seed beans, which we think is working pretty well for us, it seems like, so far. So those are all no-till. Population is 120 to 140, depending on certain factors, and again, 28-inch spacing. Seed treatment is untreated. We did several years of side-by-sides on that, and we never saw a difference between seed treatment and not. So we just went ahead and cut that several years ago. Cover crop, again, depending on the year, 55 pounds of cereal rye that I drill right after harvest. And then the same story on fungicide and insecticide. If we meet a threshold, we would make that decision with what's appropriate at the time. But one thing that I always gripe about is, when people prepay for chemicals to treat a pest that they don't know that they'll have for another 8-9 months. So, we make those decisions at the time. Historically, we've had really clean fields from a fungicide or a fungus and insect standpoint. So we don't think that will be changing anytime soon. So then just to hop into what this looks like at an implementation level, given all of those practices. So I like to think of those pests in certain buckets, and sometimes there's some overlap between our treatment of each. But really everything that we do in some way impacts each of those pests, whether it's clear or not at the time. And so what I look at as our portfolio of weed treatment, like I said, we did move to 20-inch spacing for both corn and beans a couple of years ago. That's been a really good move. That is kind of balanced out by the fact that we are no-till and cover crop ahead of corn as well. I find that our crop is sometimes a little shorter for longer. So we do probably not reach canopy quite as fast, but again, narrowing those rows helps a little bit for that. Like I said, we do band a portion of our nutrients. Used to band all of them, but that just was pretty labor intensive, trying to keep up with the planter. So we do band those. Another important thing that I have here for nutrients is we also that I don't have up there is that we stay towards the MRTN, that 180-pound range for Illinois, central Illinois. And really, I think anecdotally, I don't know if there's been any research on this, but between our farm, neighbors' farms, there's a really pretty clear difference when you start pushing nitrogen rates pretty high in the level of weed control. We've seen that ourselves, and neighbors have seen it. So yeah, that's just keeping nutrient rates responsible is certainly a part of our program as well. No-till and cover crops, that's a huge part of what we do. The suppression that you get with cover crops, but also the no-till I think is really important because we're not turning up any new weed seeds. So if you look at the survivability of a weed seed on the soil surface, what you find is that a lot of the weed seeds that we target, especially those small seeded broadleaves, don't have very much longevity on the surface, usually not more than a few years. So if we can get really good weed control for a couple of years, that really helps us out for future weed pressure, kind of like how Bryan had touched on. Within that, we also still are using chemicals. We're using layered residuals when needed. Not all the time. There's been years where we've been able to reduce the herbicide quite a bit. But what we've kind of find is that no cover crop field is ever perfect. So there's always some kind of a low spot or something that drowned out or didn't overwinter very well where we have weed pressure. So using those residuals kind of helps us fill in the gaps of maybe where our results weren't as great as we would like. And then lastly, and I'm glad that Dr. Lundgren talked about this because we kind of made some of these choices based on some of that research, is we are insecticide free because I see that as a huge part of our weed management program. So between insecticide free, between the cover crops and no-till, if we can harbor a lot of beneficial insects, and I'll talk on that on the insect slide, but if we can harbor those and they're eating all that seed, sometimes their body weight every day or something like that, that's a huge part of our program. Diseases are a fun one. I think about an hour here, I should start hearing the planes and helicopters again once the dew is off. But diseases are a tricky one, right? They can be kind of scary. They can blow up fast. So thankfully, knock on wood, I think we've been really lucky with our disease control, given the amount of chemicals that we use. So one thing that we started recently is terminating corn covers early. Again, a lot of times I am planting, unfortunately, a grass cash crop into a grass cover crop. And so there's some green bridging, right, where pests can move from one to the other pretty quickly. So when we stretch out that time, I think there's good research on reduced seedling diseases pretty significantly when you stretch that out. Though we never felt we had too terrible of an issue when we were planting green. No-till and cover crops, again, this was kind of a benefit for the weed control. But it was kind of a detriment having a shorter, later maturing crop in the weed control. But here, shorter crop, we get more airflow. The cover crops and no-till are really nice. We don't have soil splashing, which I think is a huge pathway for diseases to make it onto the plant. Also, we have relatively healthy plants. Some of these herbicides, when they bounce up on the plant, can burn them. We usually have very, very healthy plants. One cool study that we did a couple years ago now, when we were just starting to get into cover crops and no-till, to straighten out the rotation in a field, we had to do a bean on bean year, and the prior year we had horrible white mold without cover crops. And the first year that we adopted cover crops, Dad decided to do a strip out there just to see. He had read somewhere that there was maybe some impact on white mold. And so he decided a strip without white mold. And so Come a couple weeks before harvest time, took the drone up, and there was about a 35 bushel hit where we didn't have cover crops because of the amount of white mold that you can see in that strip there. So there's a lot of interactions, soil health interactions that I think are still that we still don't know, but some really cool things can happen, and we've seen that. So yeah, like I said, scouting, can't know if I'm going to have a disease so far ahead of time. So we do try to be out there at all the crucial points. It helps that I went to school for that to know that, but there's so many good resources out there that I encourage people to look at. And then, like I said, fungicide seed treatment in corn. We try not to use synthetics when we can avoid. And I think we need to do more testing here now, especially if we're not going to be planting green. But that's, I think, what IPM is recognizing when and how to appropriately use chemicals. So, I order seed. I don't want, there's more on there than people realize. I don't want an insecticide if I don't feel I need it. I don't want a nematicide that just suddenly got thrown on there. Pretty standard for a lot of companies years ago, right? I want to treat the problems that I know I have. And then lastly, insects. Again, this is one that I would encourage you to look at Dr. Lundgren's information there and some of his other work. But really how we treat insecticides is being insecticide free and making our fields as good of a habitat for insects as we can. And that seems counterproductive, but a lot of times insecticide use leads to more insecticide use. Those pests are so much more adaptive to that system than the beneficials seem to be. And so it's really cool. We've had some surveys done, and we have some pretty substantial, compared to neighbors, amount of beneficial insects out there. And so beetles, spiders, if a moth, if a beetle wants to lay an egg in the soil, it's got to get through what is just a hellish layer of ground beetles and spiders. Really cool to see that out there. Just about everywhere you turn over some residue. Again, a little bit of early cover crop termination before corn. We do see early season corn pests that fly in and love color and love field cover. So we try to be cautious of that. And we really do that by leveraging the resources that are available pretty openly. There's something that the U of I does, lets people know when to scout for moth flights, those kinds of things. But yeah, again, knock on wood, we have very, very clean and have not had an insect issue since I've been part of the operation. So just finishing up here, just what I would say is how to get started. Again, I do have the benefit of being our independent agronomist. But yeah, find an independent agronomist. There's really great ones all over the place. ISAP actually has what we call the conservation story map, where we have some independent agronomists on there. Yeah, it's just, getting a second opinion from somebody who's not trying to sell you a product, I think is really, really important. A fresh pair of eyes on your program. But, beyond that, look at your, what are you trying to treat? And sometimes that can be really broad. You could just say, I'm just trying to figure out my weed program, or sometimes it's a little bit narrower and we pick apart a species. Water hemp is obviously the one that we go after the hardest. But again, giant ragweed can be treated entirely different. So knowing that nuance. And then break down all those ways that you control that pest and then look for the gaps. That's what pests are good at, is finding those gaps in your programs. And going after those. And so really thinking about it like the pest would is really important. And then lastly, don't be afraid to change. We've changed our program basically every year, some slight shifts to adapt as things develop. But I think of all of our speakers have said, sometimes they can be bleak conversations about what the future looks like, but there's also a lot of hope and a lot of tools that you have available now to adapt those. So with that, I will stop sharing. Perfect. And we can hop into questions now.
Sure. Great. Yep. We'll go ahead and get started with Q&A. Again, if anybody has any questions, please feel free to keep dropping those in the chat for us. And we'll get to as many as we possibly can. First thing I want to do is thank our presenters for great presentations. It's great to see the diversity and perspective of, you know, what the answer is for future-proofing our farms. There's no easy answer to any of the things that farmers are facing today, and it's great to see the different perspectives presented here today. Lots to learn from everybody. So with that, I wanna dive into some questions here. First question, Bryan, to you specifically. Do you have any trials with rolling down the cover crop at the second or third trifoliate with the soybeans? The idea being that by laying the cover crop down, you can improve the weed suppression properties.
Yeah, so we have done some roller crimper trials in that nature. There's a United Soybean Board project that has multiple universities involved. So that is something that we are doing. Part of the challenge of that is trying to make sure you maintain a healthy, robust soybean crop at the same time. It's not just about the roller crimper, but also making sure that the soybeans, we've had some challenges with drainage. To be honest, poorly drained soils, and then you have a very dense mat of rye, and the field just doesn't drain very well after that. We've run into some soybean stand and disease issues, but we have done that. So it's, part of a system that needs to be managed. It's not necessarily an easy solution.
Frank, Jonathan, would either of you like to comment on that, as long as the floor is open?
Sure. Yeah. So we're meeting a lot of farmers that are trying, timing's everything with rolling down a cover. And there's an art to it as well. And interacting with farmers that are doing that as successfully, because there's a lot of them that are, it is a great way to kind of field some of these questions. Rick Clark is a great guy out in Indiana that's figuring this out. We also have full instructions if you're wanting to give this a try. We developed a roller crimper for like $5,000 from an old tillage implement. So you can use, once you go no-till, which we're encouraging everybody to try that first, you can build one of these things yourself if you have some rudimentary welding skills and some equipment. And it's all free. Go to the Ecdysis website and yeah, put some of those old things sitting in the tree line back to work for us.
Frank, do you want to chime in on that one?
Yeah, I can. Yeah, just on the roller crimping side, we've seen, I think, some really weird stuff with insects there. I think sometimes it can hurt you when you're using a lot of insecticide. I think that's where we've seen problems when we've done a little bit of work for neighbors. In our system, it felt like anytime we roller crimped, that I could find things like armyworms and cutworms, but they all seem to hang out under the mat and be chomping on the seed heads of the rye. Like I never really saw much pressure on the actual soybeans. So that's kind of what we saw. But I've also seen not great things this year for a neighbor. So yeah, I think there's a lot of nuance to that. We had a real quick follow-up on timing. Best timing is pollination. So if it's not pollinating, and that can be a day's difference, it's incredible. We've waited a day and it won't go down day one. It'll flatten on day two. And usually, if you're not sure if it's pollinating, it's probably not pollinating, because if you can't see across the field, it's probably the time to start roller crimping.
Great. A question again for all of you. Cover crops hold a lot of promise for promoting biodiversity, improving farm resilience. However, many large-scale farms can only manage non-winter kill cover crop species with a herbicide burn down in the spring. What options might we have for harnessing the power of cover crops without the continued reliance on herbicide? Ties in with our roller crimper discussion.
Well, I guess maybe I'll start with that one. So without herbicides, roller crimper has been the most popular. I've seen individuals go in with mowers on occasion. That's fairly intensive, but you can do that. You still have to manage all the residue that is, the result of that mowing operation. Of course, I'm not going to say tillage, but some do that. They will use tillage, but that's not the primary recommendation in a cover crop no-till system, to go in that direction. If you want to talk futuristic, I know of some scientists working on, we heard about the Terminator gene with Monsanto years ago. Well, there is something you can do in some plant species that would induce self-termination after a certain number of growing degree days in the spring. And so they'd self-terminate. And we have some species, it's known as a weed in southern Illinois, but little barley. We tried that as a cover crop effectively in vineyards for a couple of years, reseeds itself, and it normally gets about 18 inches tall and dies, about first week of May or so. So it's pretty good in that regard. So we need to look for new innovations, I guess, in terms of the species as well.
Yeah, I think it's about a system, right? It's not about a particular problem. It's about looking at how am I changing the way that I farm a little bit more fundamentally than just whack-a-mole farming, where you knock down the latest pest or problem. And so cover crop management becomes a part of that. And essentially what it does, what it requires, it in part, is that you start to diversify your system and have multiple options available to you, like livestock, like roller crimping, like diverse cover mixes, like diverse rotations, perenniality in that system. That looks a little different when you go down to the coffee shop and everybody else is growing corn and beans. They're going to look at you and they're going to laugh at you, right? But at the same time, that's how your farm is going to withstand this coming onslaught. So yeah, as in terms of other options for managing those covers, turn it into a revenue stream, graze it. You don't have to own the animals. Work with neighbors or something like this, contract grazing systems, those sorts of opportunities. Yep. Stacking enterprises. I'll say something really controversial. Farm smaller, better, rather than bigger and simpler. I come from the world of science, right? My metrics of success, whether I was a good scientist, were publications. How many papers did I publish? How many grants did I bring into the university? How many students did I put through the puppy mill? And at some point, it was when you step away from all those expectations and you realize that those metrics of success weren't meaningful outside of that world. Farmers have metrics of success that are not representing why you guys got into this to begin with. Okay. Buying that next quarter, whether you can afford it or not, is not a sustainable metric of success. So farming the land that you have by stacking enterprises on that in order to drawing multiple revenue streams rather than just expanding out. The more you expand, the less this is easy to become a regenerative or to attain what's possible within regenerative farming. And I'll get off of my soapbox now so somebody else can talk.
Frank, would you like to speak on that? I have a question directly for you as well.
Okay, we meandered a little bit. What do you want me to weigh in on?
How to harness the power of cover crops and reduce a reliance on
next
burn down herbicides to control overwintering species.
Yeah, I will say we tried a lot of things. We tried, I mean, just things that are crazy. And we were trying to really rely on the crimper as an option. But that proved to be inconsistent. I think mostly, I mean, yeah, you want to throw out rye and crimp it. That's great. That'll always happen. Figuring out that ahead of corn, it can be really, really tricky. And so we were doing things like reducing the maturity of our cash crops significantly by a lot, just to try to get legumes established. and struggled there. We're drilling things right after the combine. So we tried a lot of strategies to work on crimping. And I will say it's so much easier ahead of beans. I think it's challenging. I think there's a lot of people who just broadly think, oh, I'm doing cover crops, or so-and-so's doing cover crops, they're using less herbicide. In my experience, that's not always true. And a lot of times it's just basically the opposite, where some guys using cover crops are using more herbicide. And so you just really have to be careful when you go down a path, understanding if A is your goal, how do you get there? I don't know. I think I meandered in that answer too, but hopefully that kind of hits it. What's the next question?
This is my question directly for you, Frank. Being that you're farming in Illinois, where the 30-inch row is sort of the standard, can you just walk us through in a little more detail how you came to the decision on your farm to switch to a 20-inch row for both your corn and your beans? What did that look like, and what was the motivating factors behind making that change?
Yeah, I think it's kind of where things are going eventually, is narrower rows. Yeah, we had just seen, especially in weed control, like, man, if we could just narrow those up a little bit, that was going to be a big part of, especially, we were really excited about corn, seeing what that could do as well. So that was really it. It was something we talked about a lot. And then I think, honestly, we're just cheap. A nice deal came up that nobody else wanted because it was a 20-inch planter. And we bought it. So that's kind of what the decision was, is ultimately weed control is what we were going for.
I'll chime in a little bit on that just myself, because you'd mentioned the the hiring of an independent agronomist, which is the world that I came from prior to my current position, and I often encouraged farmers to switch to a narrower row, specifically for soybeans, and that meant frequently that you had to purchase a new planter, but it opened up the options of, if in the spring, if it's too wet to plant corn, you could still plant beans. And then ultimately, from a weed control perspective, closing that row sooner in the growing season means you shade the ground, and shade is the ultimate form of weed control in an agronomic system. So that said, my experience with the narrower row corn has not been all positive. So I'm interested to follow up with you specifically to see how you're doing with the 20-inch row corn. My caveat to that is my experience with the 20-inch row corn is in a seed production system. So there were some other things at play there. So, but yes, that's kind of where my experience with it would come. I guess another thing that I'd like to throw out to the three of you is, what questions might you have for one another? If there's questions about how things have been determined in your systems, or philosophy, or whatever it might be, do the three of you have questions that you would like to ask of one another?
I've got a question. Let's see. So this one's specifically for John. I'll come up with one for you for you, Bryan. But we went insecticide free, and we did it in like a really, really stepwise manner. Like, okay, we felt soybean seed treatment, there was so much data that was a direction that we wanted to go. We felt confident that we weren't going to have any kind of a profit loss doing that. And then it was a lot of trials. And there's a lot of conflicting information. Well, there's a lot of information about, the yield bump, when everybody's spraying every crop in season at this time of year. So, if somebody wants to reduce their use, how do you recommend people do that? Like, what's the first things to cut, in your opinion? And not just go cold turkey, because that can scare people.
Yeah. Well, seed treatments, yeah, definitely get off of those. Go no-till. That's huge in inspiring a lot of insect problems. And then, yeah, covers and plant species diversity. The diversity of just about every other organismal group on Earth scales directly with how many plant species are in a habitat. And if one of the goals of farming is to grow life, then plants are one of your biggest mechanisms for being able to do that. Keeping those plants on the ground for as long as you can is really the trick. And there's a lot of ways that farmers are doing that. What that does is it makes the cash crop less apparent to the insect pest, and then it also draws in a lot of natural enemies, like you were saying, Frank. And the other thing is that it works in ways that honestly we can't predict. The natural world just becomes infinitely complex really quickly. So there's symbioses that end up starting to happen that are really challenging to predict. But we know from working with farmers that these systems oftentimes work. And we don't always have to understand every mechanism behind that. Certainly that's a career's worth of research. But we're at a stage right now where we need systems that work.
Sure.
And so yeah, I don't know.
Awesome. Appreciate it. Yeah, kind of the same thing for you, Bryan. So, everything that you outlined, say a farmer's starting from zero, what are the 2 or 3 things that they should start to really build an IPM program in their farm?
Well, from, of course, a weed science perspective, the best thing that they can do to, if they want to move away from the herbicide-centric nature that we are today, cover crops has, been very clearly demonstrated as a way to do that. So you just, outcompete them, create a different habitat that isn't a monoculture of a crop system in 30-inch rows, all nice and neat. So we've done this to ourselves in terms of creating these weed problems. And we're not going to go back to necessarily the tall grass prairie, but we can get closer to that. And we don't have to throw away too many tools. We can keep a lot of tools together and be more robust. I'm saying that you don't have to eliminate, like in your case, you have eliminated herbicides, but maybe the herbicides don't have to do as much. You don't need as much of them as soon as you start adopting things like cover crops and no-till production. Because eventually with time, we think no-till, well, that's just going to invite more weeds. Because all the weed seeds are going to be on the surface. Well, that's where the insects can, prey on them, of course, and birds and other organisms, voles and field mice. So I think going to the cover crops is probably the easiest thing in today's agriculture that you can move in that direction.
Awesome. Thanks, Bryan. And again, huge thanks to both of our speakers. We appreciate you being able to join and share. But yeah, I think we did have their contact information on their slides. So yeah, please, I think if you have any follow-up questions, I think please do reach out to them or us, and we can get those questions where they need to go. I think, Rachel, if you could pop up the CCA slide here. Perfect. So if you do need CEUs after this, go ahead and scan that. We'll leave that up for just a second here. For those of you that don't have the app, please do email Rachel for that. And like I said, if there's any follow-up questions, we appreciate all of you joining today. And please let us know. We can handle some of those questions. And then last slide, Rachel. Perfect. So yeah, this ends our first session of the risk management conference. So then we will have 2 follow-ups next week and the following week, same time. And so next week's we'll be hearing from Trent Ford, state climatologist, on what he's seeing in current and future weather trends, and then how to manage that in-field with Dallas Glazik of Pheasants Forever. And then the final session we'll hear from some end users on grain on what those internal conversations look like as they're producing sustainability metrics and goals. So we hope you tune in for that. But yeah, again, we hope to see you all next time, and please reach out with any questions. Thanks, guys.